So exercise number 2, consider the following political agency model. There are two time periods, period 1 and 2. There are two politicians, an incumbent and a challenger, and a representative voter. The incumbent holds office in period 1, but at the beginning of period 2, he faces an election against a challenger to determine who holds office in period 2. In each period, the politician who holds office has to choose policy A or policy B. The voter prefers policy A. Each politician can be congruent or dissonant. Congruent politicians prefer policy A and dissonant politicians prefer policy B. When in office, each type of politician, in particular congruent or dissonant, gets a policy-related payoff of 1 from choosing his preferred policy and 0 from the other policy. So if you're congruent, you get a utility of 1 if you choose policy A. If you're not congruent, so if you're dissonant, you get a utility of 1 if you choose policy B. Each type of politician also get a non-policy related payoff R strictly larger than 0 when in office. When not in office, politicians get a payoff of 0. Politicians discount period 2 payoffs at a rate delta being strictly smaller than 1. The voter is not able to observe politician's type, but he has some beliefs. At the beginning of period 1, the voter believes that the incumbent is congruent with probability pi I. The voter is assumed to observe the incumbent's period 1 policy choice and to update his beliefs about the incumbent's type rationally. The voter believes that the challenger is congruent with probability pi C. And now let's come to the timing of the game. So the game played between the politicians and the voter is as follows. In period 1, the incumbent chooses the period 1 policy A or B. At the beginning of period 2, the election is held and the voter chooses whether to re-elect the incumbent or elect the challenger. In period 2, the winning politician chooses the period 2 policy A or B. And now let's come to the definition of the equilibrium, because it will be a perfect Bayesian equilibrium that we will use here. So an equilibrium consists of first a strategy for the incumbent which specifies as a function of his type what policy he will choose in period 1 and if re-elected in period 2. Second, a strategy for the challenger which specifies as a function of his type what policy he will choose if elected in period 2. Third, beliefs for the voter which describe as a function of the incumbent's policy choice what he believes at the time of the election about the incumbent's type. And fourth, a strategy for the voter which describes as a function of the incumbent's policy choice whether he will re-elect the incumbent or elect the challenger. Each player's strategy has to be optimal given the other player's strategies, and the voter's beliefs have to be consistent with the incumbent's strategy on the equilibrium path. So the last point here basically is saying that that given your beliefs, it cannot happen that something happens out of the belief system that you have. Okay, so if you in equilibrium believe that the incumbent, for instance, is choosing a particular policy with certainty in the first period, then this must indeed happen in equilibrium, else there is an inconsistency. So we have two questions here, which are related to the two common types of perfect Bayesian equilibrium. So first of all, in sub-exercise A, we're asked, under what conditions does there exist a separating equilibrium in which the incumbent simply chooses his preferred policy in period 1? So separating equilibrium refers to equilibrium where a player is making an action, and by this action you can perfectly infer his type from this action. So that's why it's called separating, because given his actions, you know his type with certainty. Sub-exercise B, under what conditions does there exist a pooling equilibrium in which both types of incumbent choose the voter's preferred policy in period 1? So here, in a pooling equilibrium, there is no way that you can perfectly infer the type of the player, so here of the incumbent, given his action in period 1. So that's the main difference between the two kind of types of perfect Bayesian equilibrium. Okay, so 2a, and we will solve this by, as typical and extensive for games, we will solve this by background induction. So let us first start by the end of the second period. So, independent of whether the incumbent or the challenger was elected, and I will shortcut the incumbent with capital I and the challenger with capital C. So independent of whether I or C was elected, each politician will choose a policy which maximizes his utility given his type. Okay, so in particular, it means that independent of whether it's the incumbent or the challenger, if the politician is congruent, he will choose policy A. If the politician is dissonant, he will choose policy B. So this actually here, this already finished the analysis of the behavior of the challenger, because the challenger can only do an action if he gets elected in the second period. So both the challenger and the incumbent choose policy A if they're congruent and choose policy B if they're dissonant. And the reason is simply there is no kind of continuation of this game anymore. So there is no reason for them to behave strategically in order to kind of not choose their preferred policy in the second period in order to benefit from this in the future. Yeah, so there is no benefit to this because there is no future anymore in the model, and hence this is basically the end of the analysis for stage 2 behavior, yeah, second period behavior. Okay, so now let's consider the beginning of stage 2. Beginning of stage 2. Or I think just to be consistent, it's period 2. Yeah. So in the beginning of period 2, that's kind of the stage of the game where the voter or the representative voter is deciding whether to re-elect the incumbent or the challenger. Yeah, so this is the part where the voter is coming in play. We just have one representative voter, so whatever he does is determining the winner of the election. So if he elects a politician, if he elects the incumbent, or re-elects the incumbent, then the incumbent is in charge. If he elects the challenger, then the challenger is in charge. And the voter knows or anticipates the behavior of the elected politician at the end of period 2. So the voter knows what happens at the end of period 2. So he knows that if he elects any of the politicians, and the politicians will be one of them, or independent of who of them, will be of a congruent type, this politician will choose A, and if he's of a dissonant type, he will choose like policy B. Yeah, so he can anticipate this behavior, and he knows what policy was chosen by the incumbent in the first period. Okay, so the voter, given this information, the voter maximizes his expected utility by electing the politician for whom his belief about being a congruent type is highest. Okay, so that's basically summarizing the voting behavior, because the voter knows that in the next period, only if a person is like, or a politician is of a congruent type, the politician will choose policy A. So he can only maximize his expected utility, so in period 2, by electing basically the politician who has the highest probability of choosing policy A. And the politician, from the perspective of the voter who has the highest probability of choosing A, is basically given by the beliefs of the voter. Yeah, and the belief, so belief about the challenger being congruent is simply given by pi c. Okay, so this was given in the description of the exercise. And the belief about the incumbent being congruent is given by the following. It's pi I congruent conditional on A if A was chosen by I in period 1. So if policy A was chosen by the incumbent in period 1, then this is the belief of the voter that the incumbent is of a congruent type, conditional on having chosen policy A in period 1. Now we have the second case. So basically I can copy this. We have the belief of the, we have the belief of the politician of being congruent given A. Then we also have the belief of the politician of being congruent if he has chosen B in period 1. Okay, so that's the next thing that we have. And then the belief that he's of a dissonant type is always 1 minus the according probability depending on the action which was chosen in period 1. Yeah, so basically this gives us all the beliefs that we need in order to determine the behavior of the voter. So we have the belief of the challenger being congruent, which is pi c, and we have the belief of the incumbent being congruent, which is given by those two expressions. And using Bayes' rule, we can now link these beliefs of the representative voter to the actions chosen in the first period and the general probability. So his this is called his ex ante belief about the incumbent being of a the ex ante belief of the incumbent being of a congruent type. Yeah, this was given simply by pi I think, in the exercise description. Yes. So before getting any information about the behavior of the incumbent, the voter believes that the incumbent is of a congruent type with pi I. Yeah, so if I simply write pi I without the parentheses here, I'm thinking about the ex ante belief, else I'm specifying that it's about the conditional belief. Okay, so now, as I said before, we can link those probabilities, those beliefs, in the following way. As I'm just looking into my written solutions, I think just to be consistent. Oh no, it's fine. Sorry, just forgot what I said. So the probability that the incumbent is of a congruent type, given that policy A was chosen in period 1, is given by the following. So now I'm using Bayes' rule. So it's the probability that I is of a congruent type. So in general, times the probability that is choosing A in period 1, given that he's of a congruent type. Okay, and this above here, this is simply given by pi I. Yeah, so as given in the exercise description. Then we divide this by the probabilities or the all events which lead to the policy A being chosen by the incumbent in the first period. So the first one is the one above here. So the first event is like the same as here. So I will simply copy this. Also make it a little bit smaller. Just get rid of this thing here. Plus, and I will just write it down here and then copy it above. Let's make it a little bit smaller. So the first, like how many possibilities do we have that policy A is chosen by the incumbent in the first period? So the first one is that the incumbent is of congruent type and that he chooses policy A given he is congruent. Then the next one is that he is of a dissonant type. So I equal to dissonant times the probability that he chooses A given that he is dissonant. Get a little bit smaller. Yeah, so this is kind of linking now the, so this is also pi I here. This here is 1 minus pi I. Now this is linking kind of the behavior of in the first stage and the ex ante beliefs of the representative voter about the incumbent to the posterior belief, which is the thing on the left-hand side here. So the belief that the incumbent is of a congruent type given that he has chosen policy A. Okay, so this is the first belief, but of course, obviously, there is a second belief which will be important, and that is the belief about the incumbent being of a congruent type, given that he's chosen policy B. And here we can actually copy most of the stuff from above. Oops, sorry. Okay, we just replace the B's, the A's here with the B's on the right hand side. Okay, so everywhere where you see an A, you can simply write a B. And this gives us the posterior belief. So posterior because he observed the behavior of the incumbent in the first period and now has an updated belief about him being congruent given that he has chosen B. Now, this is now kind of summarizing everything that we have with respect to the beliefs of the voter about the type or the type of the incumbent given that he's chosen a particular action in the first period. Now, we will link this to the following behavior of the representative voter. So consider the following strategy. Of the voter. If I has chosen A in period 1, re-elect I, so the incumbent, if and only if your belief of the incumbent of being of a congruent type, given that he has chosen policy A, is larger than your belief about the challenger of being a congruent type. Okay, so now we're specifying the behavior of the voter in the beginning of period 2 by saying that if the incumbent has chosen policy A in period 1, then you re-elect him if and only if your belief about him being of a congruent type is weakly larger than your belief about the challenger of being of a congruent type. And the same thing holds for a situation where I has chosen B. So if I has chosen B, policy B in period 1, re-elect him if and only if his policy, your belief about him being of a congruent type, given that he has chosen policy B, is weakly larger than your general belief or your ex ante belief of the challenger of being a congruent type. Okay, so this is summarizing the strategy of the voter, and I will confirm at a later point that it's indeed optimal given the behaviors of the other participants in this model. Okay, so now let's consider first period, so period 1. And the only one who's taking an action in period 1 is the incumbent. So the incumbent has to decide about his policy. And what he knows is that he knows his own type. And he anticipates the behavior of the representative voter in the beginning of period 2. And he anticipates as well the behavior of himself and the challenger at the end of period 2, conditional on whoever gets elected. So the strategy that we will consider for the incumbent is given by the following. Choose policy A if congruent, so if you're congruent, and choose policy B. There should be two O's here. Oops. Choose policy B if you are dissonant. This is like the feature of the separating equilibrium. So he chooses according to his type. And if the incumbent is behaving in this way, this has a consequence. So if he chooses policy A, if he's congruent, it means that the probability of him choosing A, given that he's congruent, so this is from the perspective of the voter, is equal to 1. Okay, so if the incumbent is following the strategy, then from the perspective of the representative voter, the probability that he chooses A, given that he's congruent, is equal to 1. And we will need this in order to calculate the beliefs, the posterior beliefs. And at the same time, if he follows the strategy of choosing B, if he's dissonant, it means that the probability that A is chosen, given that it's dissonant, is equal to 0. So now we basically summarized the strategy or the strategies of all participants in this model, and now we need to verify that those strategies are optimal. So what do we have? So the first behavior that we have is that at the end of the second period, independent of whether the incumbent or the challenger was elected, they will choose according to the type. So we need to verify that this is optimal. Then in the beginning of period 2, we have the behavior of the voter in forming his beliefs according to what I showed you here and the following strategy. So voting for I, re-electing the incumbent if he has chosen A in period 1 only if his belief about him being of a congruent type is larger than the belief about the challenger of being of a congruent type, and the same if he has chosen B. And finally, this is the strategy of the incumbent. That we can specify here that it's the strategy of the incumbent. So strategy of I is given by this. And now we will verify that it's indeed optimal. So verify behavior is optimal. So let's start with the end of period 2. Now, this is optimal. Behavior is optimal. Behavior is optimal since the game ends here. Okay, so nobody has an incentive to deviate. So if a challenger, like independent of who's elected, if the incumbent or the challenger would be of a dissonant type and choose policy A, they would harm themselves, and the same vice versa. Therefore, this is simply optimal behavior. So let us consider now the beginning of period 2. Beginning of period 2. Now, given the strategy of the incumbent in the first period, the voter has the following beliefs about the type of the incumbent, depending on his chosen policy in the first period. So, his posterior belief about the incumbent of being a congruent type, given that he has chosen policy A in period 1, is equal to 1, and his posterior belief about the incumbent of being a congruent type given that he's chosen policy B in period 1, is equal to 0. And this is clear if you take a look at the formulas here. So given the behavior of the incumbent in period 1, which was summarized here, we know that the probability of having chosen policy A conditional on being congruent is equal to 1, and having chosen A given that he's dissonant is equal to 0. Hence, what will happen is that this term here is 1, and this term here is 0. Okay, so at the end, the belief will be equal to 1, yeah? And the same, like here, this will be 0, this will be 1, and this will be 0, and at the end, the belief about the incumbent being of a congruent type having chosen policy B is equal to 0. Yeah, so that's the way that you can calculate it. Okay. The beliefs are consistent because they were derived using Bayes' rule. Now, his strategy, so the strategy of the voter, is therefore given by the following if those are his beliefs. Re-elect incumbent, so re-elect I, only if he has chosen A in period 1. Else, elect the challenger. And why is that? Well, so why is this optimal? Well, the reason is if the incumbent has chosen policy A in period 1, then you know that your belief about the incumbent of being a congruent type, and A is equal to 1, this is strictly larger than your belief about the challenger of being a congruent type and choosing your desired policy. And this in turn is larger than 0, which is your posterior belief about the incumbent of being a congruent type, given that he has chosen policy B. Yeah, so indeed, this behavior, which is induced by your beliefs, which you derived by Bayes' rule, given the behavior of the incumbent in the first period, is optimal. So there is no way that you want to deviate from this strategy as the voter, as the representative voter. Okay. Next, what we need to do is that we need to consider the strategy of the incumbent in the first period. So period 1, we need to verify the behavior of the incumbent of being optimal or not. So when the incumbent is congruent his utility is given by the following. So, of course, his utility, if everybody is behaving according to the strategies that I described before, then his utility is given by R, which is his utility of being in office in the first period, plus his utility of having choosing a policy, so the policy A, which is according to his type. This will give him an additional utility of 1. And if he is congruent and he chooses policy A, he will be re-elected with certainty in the second period. So he will again get R plus 1, but this will be discounted by delta. So in total, his utility is 1 plus delta times 1 plus R. When I is dissonant, his utility is given by the following. So if he's dissonant, he chooses policy B in the first period, so he gets R plus 1. And in the second period, he will not be re-elected because we are in a separating equilibrium, and the voter knows for sure that he is not a congruent type, so he will choose policy B again if he's re-elected. Therefore, his utility is simply given by 1 plus R. Now, what we can do in order to verify that this is indeed optimal is that we can consider deviations of the incumbent in the first period. So let us check for deviations. So I chooses A for both types. In period 1. Now we need to consider the cases when he's congruent and when he's dissonant. So if he's congruent, then his utility is still 1 plus delta times 1 plus R. Okay, so nothing changes here, but if he's dissonant, there is a change because he chooses policy A, which harms him in the first period because he's dissonant, and then he's re-elected for sure in the second period, such that he can choose then policy B, which is then maximizing his utility, at least in the second period. So as a consequence, if he is of a dissonant type and will choose A for both types of policies, he will then simply get R because he's like in charge in the first period, but he's not choosing his preferred policy. That's also, he's only getting R. And to this, we add the discounted utility of being re-elected in the second period. Now, when is this deviation profitable? So obviously, there is no difference when he is of a congruent type because he will receive the same utility. But there is obviously a difference when he's of a dissonant type. So this deviation is profitable if and only if his deviation when he's of a dissonant type, so R plus delta times 1 plus R, is larger than his utility when he's behaving according to the strategy in equilibrium that I described before. So if this is larger than 1 plus R. And this is equivalent to delta times 1 plus R being strictly larger than 1. So if this condition holds, then the deviation is profitable, else it is not profitable. So if either the incumbent is impatient or his utility of being in office is very small, the deviation is not profitable. We can check for other deviations as well. So we can also check if I is choosing, for instance, B for both types in period 1. But that's like kind of a trivial case because in this case, or it's not trivial, but it's basically the same as in this like in this situation here that we have in when he's choosing A for both types in period 1. Yeah, so the steps are similar, and you will actually see that this will be the more crucial bind or the more kind of more binding condition for the deviation to happening. So the deviation of I choosing A for both types in period 1 is more profitable for the incumbent than a deviation where he's choosing B for both types because the voter prefers A before B. So this will be the crucial kind of condition which determines whether a deviation is profitable or not. So what we can summarize now is that the incumbent has no incentive to deviate if delta times 1 plus r is greatly larger than 1. Therefore, if this condition holds, a separating equilibrium exists. And this finishes sub-exercise A. So now we derived a condition with respect to the primitives of the model such that a separating equilibrium exists. And the equilibrium is given by the strategies that I described to you before. And this brings us to sub-exercise B, where we were asked to derive conditions such that there exists a pooling equilibrium in which both types of incumbents choose the voter's preferred policy in period 1. Okay, so now I is choosing A for both types. Now, both I, consequence of this is that both I and the challenger C have an incentive to deviate from choosing their preferred policy at the end of period 2. Now, let us consider the beginning of second period. So now the issue is that given this behavior of the incumbent that he's choosing A for both types, the voter cannot infer the voter cannot infer the type of the incumbent by his choice or his behavior in the first period. Now that's an issue because now, if the voter is not able to infer the type of the incumbent given his behavior in the first period, all that he can do is that he can rely on his ex ante beliefs. So therefore, the voter has to rely on ex ante beliefs pi I and pi c. Okay, so he cannot infer any information. Therefore, the only thing that he can do is that he needs to consider his ex ante beliefs. Now, what we wanted to derive is that we wanted to construct an equilibrium where the incumbent is choosing his preferred policy in the first two periods. In the first period. Okay, so a consequence of this is that the incumbent will be re-elected only if pi I is larger than ci. Pi c, sorry. Now, given this behavior of the voter, that he will re-elect the incumbent if and only if his ex ante belief of the incumbent of being of a congruent type is higher than his belief about the challenger of being a congruent type. Now we can check whether the behavior of the incumbent in the first period by choosing policy A independent of his type is optimal. Now, what we showed in the previous sub exercise is that, so let's just to give it some structure, let's go and say that this is the period 1, so this is period 1 here. In A, we showed that the incumbent has a profitable deviation to choosing policy A for both types if and only if delta times 1 plus r is strictly larger than 1. Or was it the other way around? Let me just check to be sure. Exactly. So if this condition here holds, then there is an incentive for the incumbent to deviate from the separating equilibrium kind of behavior to the pooling equilibrium behavior where it's choosing policy A for both types. So if this condition here holds, then the incumbent has no incentive to deviate to the separating behavior again, because his utility is simply larger if he's choosing the voter preferred policy in the first period in order to make sure that he will get re-elected in the second period with certainty. But of course, in this situation here, that's not the only condition which must be fulfilled, because we need a second condition, which is that the behavior or the belief of the ex ante belief of the voter needs to be larger for the incumbent being of a congruent type than for the challenger of being a congruent type. So second condition we need is the ex ante belief about the incumbent being a congruent type being larger than this probability of the challenger of being a congruent type. Now we can check whether the voter has an incentive to deviate from this behavior that I described before. So does the voter have an incentive? It's one voter. So does the voter have an incentive to deviate? Given the behavior of the incumbent, where he's choosing policy A independent of his type, he will re-elect the incumbent with certainty. So given behavior of I, he will re-elect I with certainty. And this gives him an expected utility of the following. So his expected utility of the strategy is pi I times whatever utility he has when his preferred policy is chosen. Let's say it's 1 plus 1 minus pi I, of course. There can also be the case that the incumbent is of a dissonant type because he cannot infer it from his action in the first period. Then he will get 0, so this is equal to pi I. And a deviation could be by the voter choosing or electing the challenger. So deviation, choose challenger in period 2. And this will give him the following utility. It's then the ex ante belief of the challenger of being of a congruent type times the utility, which I just said is equal to 1, plus 1 minus the probability of being of a congruent type for the challenger times 0, and this is equal to the probability of, or the ex ante belief of the challenger of being a congruent type. Now, this deviation is not profitable if pi I is larger than pi c. And this was the condition that I assumed in the beginning here. So now we basically have two conditions. So a pooling equilibrium exists if delta times 1 plus r is larger than 1. So this condition is making sure that the incumbent has no profitable deviation, and in addition, if pi I is larger than pi c. This is making sure that the representative voter has no incentive to deviate. And yeah, those are the conditions which are then sufficient for a pooling equilibrium to exist. And yeah, with this, we are finished for this problem set, for the problem set of this week. So see you next week.